Hello and welcome to Hyfindr Clips. Today we'll discuss the design for shock and vibration in fuel cell stacks. Okay, you did mention shock and vibration as another interesting topic to quickly look at.
Yes, and that's something that sometimes gets a little bit overlooked and can actually affect how many cells you will put in the stack. So when we look at a stack, we have a center of gravity, and we can have shock loads in any of three directions. And depending on the application, it may come more in one direction and the other direction. So for example, if you're in a marine application on a ship, you may have bow slamming or stern slamming where the ship comes out of the water and hits it down, and there will be a large shock in the z-axis. If you're in an automotive application, you may have some road load, and you may also have a shock requirement in a crash situation, which would more be in the x-axis. And if you're in a train, there will be shock loads from when the cars hit together, and there may be a shock in another direction. So all those have to be considered when we're designing the stack. And how that affects the number of cells is that when we stack them one against another, these cells all have gas diffusion layers, which are made of carbon fiber paper and are compliant, as well as seals that are meant to compress under the stack load. And as you stack up more and more and more of these cells, it becomes very squishy and less solid. Well, the one next to me is under compression and is very solid. But if you think about extending this higher, higher, and higher, you end up with this deck of cards. And if you have it in the direction that's shown on the slide, and you start to apply either a shock load or a vibration, then even a small shift in one cell to the neighbor can result in an overall bow of the stack, in which case you may violate your clearance distance, which is the distance you want from your high voltage system to your grounded system. Or if you make contact, you might actually have a ground fault. So these kinds of things have to be simulated and tested, and you have to see how many cells you can put in a row before you might run into a problem like this.